So I'll be talking about what is artificial intelligence and machine learning, the Turing test, and about Chinese room analogy for AI, and the perspective of the top thinkers about artificial intelligence. What is the difference between AI and ML? And I'll also be talking about building blocks of AI and building blocks for a self-driving car. So let us start by developing an understanding of what is artificial intelligence and machine learning is. So sadly, the definition of AI is not being clearly defined at the first place. So right now, a lot of people are talking about artificial intelligence. There are no agreement on how design and how we can really measure this intelligence is there at any place. A lot of people believe an artificial intelligence is about some kind of a cyborg or species which can act like humans. If I talk about an informal definition of artificial intelligence over the year has been whatever machine cannot do yet, but humans can. For long period, people argued that it would take true intelligence to play chess, right, or simulate conversations or recognize an images. We have been able to achieve few, but every time the barrier was broken, the meaning of artificial intelligence has evolved. So, generally speaking, artificial intelligence can be defined as the field of development of intelligent machine that work and react like humans. So, these activities could be, seeing like humans or computer visions, listening like humans, or speech recognition, or taking a rational decisions like humans, right? So creating an AI is a long standing for humans so that we can unleash this power and get to more done in a limited lifespan. So one of the early attempts to measure artificial intelligence of machine was done by Alan Turing, so which is popularly known as the Turing Test. So that this test was created by Alan Turing in 1950, and which simply says if machine exhibits intelligent behavior such that a human cannot tell the difference between machine and a fellow humans, then machine is said to be an intelligent, right? So as you can see in this figure, a human is denoted by C. Okay, so let's say if this human, which is denoted by C in this figure, interacts with two entities, that is A and B, through messages. If the machine is truly intelligent as defined by the Turing test, the human C would not be able to distinguish between the machine or the human, right? And also, if you would take a look into one of the demos given by Google for its assistance, Google Duplex, right? So that, I mean, duplex, you could see that it is very difficult for the person on the other side of the call to tell whether it was interacting with the machine or a human, right? So while Turing test is a good benchmark, John Searle came out with an analogy called Chinese room analogy in response to the Turing test. This analogy states that though the machine might act like an intelligent machine, it does not mean that it has intelligence of its own. For example, consider a room where you can, send messages in a Mandarin as an input and get the output in a Mandarin. All this person here, what it is doing is it is taking an input, mapping to the huge dictionary of responses provided it maybe beforehand, and telling the output as per the dictionary. So if I have to say in other words, even though the person is only doing the mapping from the dictionary, it might appear that the person actually knows and understands the Mandarin. So this essentially means that even if the machine clears the Turing test, it might not be intelligent because everything is getting referenced by this dictionary. It is not something that machine has its own intelligence to map, right? So now that we understand there is not a standard definition of artificial intelligence, let's take a look at some of the top thinkers, what they really think about artificial intelligence. So the legendary, Google founder Larry Page, what he believes that artificial intelligence would be ultimate version of Google. On the other hand, Andrew Ng believes AI is more like an electricity. As you can see, each of these thought leader has their own versions and thoughts about what artificial intelligence can do. But one thing is very clear, though these statements, that is artificial intelligence will have a huge impact across several fields, simultaneously. So the next question, is what is machine learning, right? So, and just a word of caution, you might see artificial intelligence and machine learning being used interchangeably over the internet. So if artificial intelligence is pursued to create a human-like, systems, machine learning can be thought as the brain behind these systems, right? So basically, what I can, understand is artificial intelligence is much larger field of study and includes things like robotics, design thinking, etc. Whereas machine learning is the brain of this machine, which can look at historical data and can make a prediction according to them. Later on, we can, see about special machine learning techniques called deep learning, which are used to do some of the tasks like computer vision, voice recognition, and deep learning is kind of a subfield of a machine learning, which itself is a part of a large field of artificial intelligence, right? So with this image, it is very much it's very much descriptive. So let us take a look at schematic to understand what is artificial intelligence and machine learning and the differences in the two. So let us represent the real world through this box here. Now, in order to understand what is happening in this real world, right? So we need to capture the data about the real world, and this happens through the sensors. And I am going to give a very good example later on, but just try to understand that, how this happens in the real world first. So as you could see that this we can, get it from the sensors, and the data gets captured in various forms, like it could be like image, it can be a voice recordings, it can be through text or atmospheric readings. Once you have this data, we extract information from this in the form of so-called features, right? And this goes as an input in the machine learning model. For the sake of simplicity, we can understand these features as a variables, right, which tell information about the outside world to the machine learning model, right? Let's say, for an example, if you're creating an artificial intelligence system which maintains the temperature of your room based on how many people are there, right, time of the data, then month of the year, etc. So then your AI system needs to take all this information in the form of features. So there would be one feature as a number of people, right? One for the current temperature, and another for time, and another for month, and so on and so forth, right? So next, this machine learning model will take information from these features and run the model, right? So this is done by using the algorithm and techniques, which we will take a look at it later, because that will be like another topic. But then right now, we'll just try to understand how it works, right? So the model might also interact with the simulation, right? So here you can see that, it's a simulation. So this is like another, kind of model that gets attached to it. So after that, this is done by using various algorithm and techniques, as I told, which will, this model might also interact with the, simulation engines as required, like any simulation engine. Let me give you an example. For example, in case of a room control system, we might first understand who all are present in the room, right? Which is done by machine learning engine, and then simulate what could be the next set of actions. Combine the machine learning model and simulation engine will then provide you with the output. right? And this output will further be taking an action, and these actions are then taken by the real world actuators and humans. So these entire systems, which are started by taking the input from the real world and taking action in the real world, is a physical representation of the AI system. I hope it is a little bit, okay with what I have told. But in case if it is not, then I'm also going to give you a real-time example as well. So let's take a dive on that. So as you can see, machine learning, sits at the heart of the system and is the brain running the entire system. Right now that we got an overview of artificial intelligence and machine learning are getting so much attention, let us take a look at various components of an AI artificial intelligence system. I will give you an overview of different components in an AI system, and then we'll understand these components with the help of the self-driving car. As you might expect, every AI system needs a lot of data to function, right? So ultimately, it will take a decision based on the data it captures. Because earlier we have seen that it does not have its own brain. So definitely, if it has to take any decision, it has to be on the basis of the data what it is going to capture. So it needs to capture data about the environment, about the ambient condition, or user inputs, so on and so forth. Hence, the first component of any artificial intelligence system is the way it captures the input in the system. This could include like various sensors that I have shown you in the above diagram, right? It could be the sensors could be like camera, GPS locations, or user inputs from mobile apps, etc. So in order to select the right input, you need to think what all data you need to capture, like how frequently do you need to capture this data, or how fast would this data flow, or what could be the best ways to capture this data. At times there would be a multiple ways to capture the same data. For example, you might rely on sensor in your car to capture weather information, or you might directly pull them from the internet based on your GPS coordinates of your car. It might make sense to weigh the pros and cons for the various ways to capture, but it all depends, or these are the factors, these are the deciding factors. So once you capture this data from the input units, you would need to either store it or run or compute on it, right? So both of these can either happen on the system, typically called AI on the edge. Let's take a look just take a look into that. So I'm talking about this. So this could happen either on the edge, or this could happen either on the cloud. So you need to decide what data would get stored in the edge. Like computation should happen on the edge, where you would typically have a limitation on the computer environment. These are like some of the decisions, like where you want to store the data on the edge or whether the cloud. So this is basically on the, with the limitation. Let's say if you have a limitation of the environment, compute environment, right? And what would happen on the cloud typically if there is any, like, let's say if there's any critical operation, which should happen even if there is no internet connection, or if there's any upgrade of the system, it will always happen on the edge. So this would include things like, on the way decisions, alerts, or any form of monitoring you would want on the device. Such things will happen on the edge. Rest of the things can happen on the cloud. So more comprehensive data, and let's say if you have more comprehensive data, right, and computation happens in the cloud. This is where the data scientists and engineers, they apply various machine learning techniques to make the system better. All your data lakes, data warehouse, etc., would typically be on the cloud itself. Finally, there would be an output or interaction unit. This is the unit where artificial intelligence system would interact with the outer universe and take action. So this could be in the form of display and in the way of voice output, or in the form of robotic actions. Usually the output from the system would have like several designs as well. Right, I'll just give you a short example. If the vehicle is not able to, decide or read the environment with certainty, what should it do? It should stop first, or it should, alert the users. So basically, how frequently, in what details you should communicate with the users. These are some of the questions which would come in consideration in the output layer of an AI system. And finally, I'll take an example of, how exactly we can understand. Now, since we understand all the components, we've also seen how it actually happens in the real-time environment. Now, we'll just take an easy example of building blocks of a self-driving car and how it works, right? So As you would expect, the first component as an input, as we've already discussed earlier, as you can see, self-driving car takes the input from the several sensors, right? You can see the sensors in the blue colors. These are all called light-based radar system, and in addition to these are the cameras. There are sensors which capture weather and so on and so forth, right? And then there is a component called storage in the car itself, which enables the car to take decisions like how much to steer, what speed to run at, and what are the obstacles on the way and how to handle them. So there is also a storage on the compute layer, right? On cloud, which is responsible for making the driving algorithm better over time. And finally, you would see several output components like screen, um, for showing messages for the people around, and if there are also action taken by the robotic process to drive the vehicle forward. So yeah, so that's it. So with this, I will we will further discuss this in more details, but given the